All right, so in this question, we have a pendulum basically, and we have some questions about it. So let's write down the givens, and then we can discuss what the questions are and how to approach them. So we have the cord. The object has a mass of 0.500 kilograms, and the radius, it swings in a vertical circle. The radius is 2 meters. It's kind of funny how they don't use the word pendulum to describe this. It makes me a little worried that I'm misunderstanding, but I'm just going to roll with it. So theta is 20 degrees. And the velocity, or the speed, I'll still call it v for velocity, is 8 meters per second. So I'll go ahead and just draw this here. So here's our R. Here's the mass. Here's the angle. And then here's its velocity. And first we want the tension in the string. So so what we want to do is approach this like you would approach any of these problems, making a free body diagram and writing sum of the forces equal to MA, and we want to see where that gets us. So we have this is dot represents the mass. We have the weight down, and we have the tension up. And so now we want to write down the sum of the forces is MA for either direction. So I'm trying to think what the best way to make my axes are. So usually with a pendulum, I kind of would just do like X and Y like this. But I kind of have a feeling we're going to be focused on the centripetal acceleration, and that's going to be useful to us. And so then I would want to make the axis like along the string. I'm going to pause and read the rest of the questions to help me decide. Okay, the rest of the questions are about the tangential and radial parts of the acceleration. And so I will choose this basis. So this is like along the string, and this is perpendicular to this. So I'll just like overlay this so that it's totally clear. So I'm going to call this one X. Well, actually, maybe I should label it T and R for tangential and radial. And I've never done that before, but let's do it. So we want to do the sum of the forces is MA. And so let's do which one's easier? Let's do tangential. Not sure if it's actually easier. So the sum of the forces along the tangential direction are just the weight, and we just want this component of the weight. So let's see. So that's going to be either times the cosine or the sine of 20 degrees. And I'm going to be like slightly lazy and just do it by not drawing it out, but by thinking what would it be for 0. So if the weight was just totally down, then our X and Y would be like this, and our tangential and radial would be like this, and there should be no component. And that would be theta equals 0. So then I know it's sine of theta because the sine of 0 is 0. And so that works out, or that checks in that limit. You could also just draw out the triangle. I just felt like doing it in this slightly different way. But anyway, that's this component of the weight vector. And that's the only thing going on in the tangential direction. So we're all done with the sum of the forces side, and we can just set it equal to MA. And so that doesn't even really give us tension. That's okay. I think that'll help us for the latter questions. And now we want to do the radial direction. And so we want to do the sum of the forces. So we have, let's say that up is positive. So then we have the tension in the rope, and then we want to subtract out the weight because there's the vertical component of the weight, and that's going to be weight cosine of theta. And we want to set that equal to ma, and we know a is centripetal, so it's going to be v squared over r. So that is our AC. Now let's think about what we want to solve for. For A, we really want the tension, so I think this equation is going to be best. We can do weight is mg, bring this to the other side, and then we have tension. So we have tension equals m times g cosine theta. Again, that's just the weight, this subbing in mg and bringing it to the other side, plus v squared over r. And now what I want to do is just plug this into a calculator, and then that will get me the answer. So mass was 0.5, and we want to multiply that by 9.8 times the cosine of 20 degrees plus 8 squared, 64, and we want to divide that by r, which is 2. And so that gets me 162 newtons. Great, and then let's see what the next question is. Oh, that's slightly different than, I can see what somebody else got. I'm gonna pause this. I made a calculator error. It misplaced some parentheses, so it's actually 20.6. So what else could this be? Okay. 20.6 newtons, great. And now we want the tangential and radial components of the acceleration. And so for the centripetal, I'm going to call it, sorry if it's confusing, it's AC is the radial component. That's the traditional symbol for it, so I'm just going to use that. That's v squared over r. And I can actually do that in my head. 64 divided by 2 is 32 meters per second squared. Oops, sorry, I'll turn my computer on do not disturb. Sorry for the pause there. I thought I paused the video. Okay. Oh, and then we need the radial component. And so the radial component is just going to be this A. So this is, or sorry, the tangential component is just going to be this A. And so we want to solve for it. And so that's just going to be, if we plug in for weight is mg, we'll get, the m's will cancel, and we'll get A tangential is g sine theta. Let me write that out so I'm totally clear. So just kind of doing some algebra here, we have mg sine theta equals ma tangential. Those cancel, and so you get the tangential component is g sine theta. And so I'll just kind of keep writing down my answer here. So A tangential equals g times the sine of 20 degrees, so 9.81 times the sine of 20 degrees. So that's 3.36 meters per second squared. And for C, we want the total acceleration. And so the total is just going to be the vector sum of these. These are perpendicular. And so, so like, right, AC is going to be, all right, inward, and then AT is going to be like this. And so the sum is going to be something like this. And so the total is just going to be 32 squared plus 3.36 squared. And if I plug that into a calculator, let's see what I get. 32 squared plus 3.36 squared. And I get 32.2 meters per second squared. And I probably should put this in like the actual vector form. This is the magnitude of it, but let's figure out the angle. So I'm just gonna like redraw it, but at a different angle. So here's our A tangential, and then A centripetal is like is bigger. AC, so A total looks like that, and then this angle theta is so the tan of that theta. I already used the symbol theta. I'm gonna call this phi. Is going to be equal to AC over AT, and then phi is just the arctan of 32 over 3.36. Two degrees, and so that gives me 84 degrees. And I just realized, I mean, this whole thing is going to be at some kind of angle with respect to, like these axes are, you know, not perpendicular and parallel to gravity. So I'm just going to kind of leave this information, and I'm not sure exactly what type of answer you're particularly looking for. I mean, this has all the information, but not necessarily in the proper form that you might be looking for. And then you want to know if it's swinging down to its lowest point instead of swinging up. And then no, nothing in our answer used anything about the direction of the velocity. So I would say no. And then explain your answer. It's just because the free body diagram is the same, and then nothing depends on the velocity.